What if you showed a computer 100 pictures of your cat, and it learned to recognize your cat perfectly? But then, it failed to recognize any other cat. That's weird, right? You'd think it learned what a cat is, but it actually learned what your cat looks like. This is a big problem in machine learning, and it's called overfitting. You'll learn what that means, and how computers can learn to generalize, not just memorize. Imagine you're trying to learn a new game, like chess. You practice with your friend, and you get really good at beating them. But then, you play against someone else, and you lose. That's because you learned how to beat your friend, not how to play chess in general. This is kind of like what happens with overfitting. The computer learns the specifics of the data it's trained on, but not the general rules. You can think of it like a student who memorizes a math formula, but doesn't understand what it means. So, how does overfitting happen? Well, when a computer is trained on a dataset, it tries to find patterns in the data. If the dataset is too small, or if the computer is too complex, it can start to fit the noise in the data, rather than the underlying patterns. Think of it like trying to draw a line through a bunch of points on a graph. If you have too many points, you can make the line fit all of them perfectly, but it won't be a very good representation of the underlying trend. The computer is essentially doing the same thing, but with millions of points and millions of lines. Let's look at an example. Imagine we're trying to train a computer to recognize pictures of cats and dogs. We have a dataset of 100 pictures, and we train the computer on it. At first, it does pretty well, but as we add more complexity to the computer, it starts to overfit. It learns to recognize the specific pictures in the dataset, but it fails to recognize new pictures of cats and dogs. We can see this happening by looking at the computer's performance on a separate test dataset. As the computer gets more complex, its performance on the test dataset gets worse, even though it's getting better on the training dataset. So, why is overfitting a problem? Well, in the real world, we want computers to be able to generalize, not just memorize. We want them to be able to recognize new pictures of cats and dogs, not just the ones they've seen before. This is especially important in applications like self-driving cars, where the computer needs to be able to recognize and respond to new situations, not just the ones it's been trained on. So, to recap, we learned that overfitting is when a computer learns to recognize the specifics of a dataset, but not the underlying patterns. We learned that this can happen when the dataset is too small, or when the computer is too complex. And we learned that it's a problem because we want computers to be able to generalize, not just memorize. The key takeaways are, overfitting is a common problem in machine learning. It can be caused by small datasets or complex computers, and it can be prevented by using techniques like regularization and early stopping. Next time, we'll learn about some of the techniques that can be used to prevent overfitting, like regularization and early stopping. We'll also learn about some of the other challenges in machine learning, like underfitting and bias. Don't forget to subscribe for new lessons every week, and we'll see you in the next video.